Hi everyone, this is Manas and I'm back with another video for all the aspirants of engineering services examination. And guys, today we'll take on problems based on projection of line. So here is the first problem. Take a look at this. Let me go ahead and read this. If a line is parallel to both HP and VP, line is parallel to both HP, horizontal plane and vertical plane, then its true length will be seen in. Okay. To find the solution, let us take a look at this animation. Well, there is this VP, there is HP, both of them are principal planes, and we'll try to keep a line in such a manner that it is parallel to both HP as well as VP. Now try to take the projections from the front, okay, that's the front view, and now let us take a look at this line from the top, that's the top view. So what we've been asked is, the true length is seen in, well, you can see the true length from the front and you can also see the true length from the top. So true length is basically visible from both front as well as top. So the right option is option D, both front and top views. I hope that was easy. Okay, now let's switch over to problem number 2 and please read the description and let me read it out for you. A point at which the line intersects the VP, okay, extended if necessary, is known as. Now guys, if you have seen my videos on traces of line, this is something which happens. If you have a line which is either inclined to HP, inclined to VP or inclined to both the planes, if on extending the line it meets principal plane at a particular point, then that point is known as a trace. And here, in this case, the line on extending meets the vertical plane, then that is what you call a vertical trace. Remember this, if on extending the line it meets the vertical plane at a particular point, it's a vertical trace, and if on extending the line it meets the horizontal plane at a certain or at a particular point, that is a horizontal trace, right? Now, one more thing which I would like to tell you, if a line is inclined to both HP and VP, then we'll be getting two traces, that is, we'll be getting a horizontal trace as well as a vertical trace. One more thing, if the line is only inclined to HP and it is parallel to VP, then we'll only be getting a horizontal trace. If a line is parallel to HP and say inclined to VP, then in that case we'll only be getting a vertical trace. So line inclined to HP, horizontal trace, line inclined to VP, vertical trace, and line inclined to both HP and VP, well, both the traces HT as well as vertical trace. So that was the entire idea for problem number 2, and the right option is option C, that is a vertical trace. Now let us take a look at problem 3, and here we go. If the front view of a line is parallel to the XY line, its true length is shown in. Let me demonstrate that to you. That would be very good. And here we go. So let us have a vertical plane like this, and let us also have a horizontal plane. Yeah. Okay, that's VP, that's HP. Now what we are going to do is we are going to keep a line like this. Like this. Now this line is actually inclined to the vertical plane, let me tell you. If I can just, this angle right here is the angle made with the vertical plane. Let's say this end of the line is represented by A, this end is represented by B. And if I were to take a look at this line from over here, that is from the top, its projections would be somewhere, let's say here, let's say here. Looks pretty good. And this point, guys, let's say this point is represented by A and this by B, and this over here, if I can just connect A with B, that is the top view, which also is equal to the true length. Why? Because this line is parallel to HP and it is inclined to VP. Okay, and in that case the front view, and this is something which has been asked to us in the problem, its front view will be somewhere here. Let me try to make it. It's a bit difficult to draw everything in 3D. Like, okay, something like this. If you try to take a look at this line from over here, this is where it's going to be. Yeah, somewhere here. And this is precisely this is the front view of the line, and if I want to mark the end points, it would be A dash and B dash, and you can clearly see that this front view is absolutely parallel to this X, Y line. Then in that case, the top view will show the true length. So what is the right option? Where is the page? The right option is, if the front view of a line is parallel to the XY line, the true length is shown in the top view. So this is basically the right way to interpret and approach this particular problem. Now guys, I've made this on a plain sheet of paper. You guys have to run this animation inside your brain, and then only you will be able to figure out the right option. Okay, so try to train yourself, try to think in this manner, and then only you will find yourself well at ease. Okay, problem number 4, and here we go. If the top view of a line is a point, so the top view is a point, the front view is, top view of a line is a point. Okay, let me have the reference plane, VPHP. Top view appears as a point. The correct option is this. See this line right here is perpendicular to the horizontal plane. That's why the top view is a point. Okay, so what are the options? It is perpendicular to the front view is. So how would the front view look? The front view will rather show the true length, and which will also be perpendicular to the XY line. So the correct option is option C, perpendicular to XY line and of true length. Beautiful, isn't it? Let me explain that once again. So there is this line, okay, kept in the first quadrant. We've assumed it to be in the first quadrant, above the HP and in front of VP, in such a manner that this line is perpendicular to HP. In that case, the top view of the line will show a point, okay, or rather the line would appear as a point. And when you take a look at this line from over here, that is from this front, that front view will in fact show its true length, and in case of projection, in case of front view, it will be absolutely perpendicular to this XY line. Okay, that's it. So the correct option is option C. 4 questions done. Let us move to question number 5 and let's see what it has got. So the problem number 5th is horizontal trace of a line exists. When does the horizontal trace of a line exist? Okay, there are 4 conditions, and one of those is the right option. Anyway, horizontal trace of a line exists. Okay, when do we get a horizontal trace? Just take a look at this animation. We've got VP and HP, and we've got a line, and this line right here is inclined to the HP. As I've told you in some of the problems, or rather in one of the problems just for this one, if the line is inclined to HP, take a clear look. The line is inclined to HP, and if you extend this endpoint A, it will meet the horizontal plane somewhere. Okay, wherever it meets, we have the trace. What trace? We have the horizontal trace. So remember this, guys, this is something which is going to be very beneficial for you. If the line is inclined to HP, you will always get a horizontal trace, and if the line is inclined to VP, you'll always get a vertical trace. So the correct option is option B, and that's inclined to the horizontal plane. Done. Let's move over now to the next problem, and that's problem number 6. Very interesting. Let me read that for you. If a line is inclined at 45 degrees to the HP, okay, I would need this 45 degrees to HP. So any angle associated with HP is theta, that is 45 degrees, and the inclination of this line with VP is 30 degrees. Phi is 30 degrees. Okay, the front view is inclined at. Now in order to understand this, guys, there is something of a line diagram which you need to remember. Okay, please take a careful look at this figure. Now this is something which we associate when a line is inclined to both HP and VP, and based on that assumption, this entire diagram has been made. So this is basically the front and top view of a line inclined to both HP and VP, say at an angle 45 degree with HP and angle 30 degrees with VP. In that case, you can clearly see this over here is the final front view, and that's the final top view. A dash B dash represents the final front view, and AB represents the final top view. The angle that the final front view makes with the XY line is alpha, and the angle that the final top view makes is the angle beta. And you can clearly see angle alpha, no matter what happens, angle alpha is always going to be greater than theta, and at the same time this angle beta will always be greater than the angle phi. So do we have an option? Okay, the front view is inclined at more than 45 degrees, more than theta. That is the right option. Option D. Done. Very easy. Okay. Always remember, if a line is inclined to both HP and VP, theta, not theta, but alpha will always be greater than theta and beta will always be greater than phi. Always true. Okay, problem 7th. This is very interesting. Okay, so here we go. If a line is inclined at 30 degrees to the HP, okay, and 60 degrees to the VP, 30 degrees to the HP and 60 degrees to the VP, its front and top views are inclined at an angle of, very interesting. Okay, theta is equal to how much? 30 degrees, fine, and phi, that is the angle that the line makes with the VP, is 60 degrees. If you add these two, you will have theta plus phi is equal to 90 degrees. This is a very unique case. This is a very unique case, and let me tell you why. Okay, so just take a look at this diagram. HP, VP, and there is a line which appears like a ladder, isn't it? Ladder, and that vertical plane is a wall, you can say, and this portion, the bottom portion, is a floor, you can say. The angle that it makes with the wall is the angle that it would make with a vertical plane, and that has been given to us as this 30 degrees or 30 degrees with the wall angle made with VP, that is 60 degrees, and the angle that the bottom end of the line makes with the ground is the angle that it would make with horizontal plane, and that is 30 degrees. Okay. Now these two angles can be changed, but they are always going to follow this property. Whenever it has been put up in the form of a ladder, it is always going to follow this mathematical property. In that case, when you take a look at this line from the front, you will have an absolutely perpendicular line with respect to xy, and whenever you take a look at that line from the top, again you will have a perpendicular line, perpendicular to xy rather. So both front and top views are perpendicular to xy. Okay. So do we have an option? We've got an option in the form of option C, both at 90 degrees to xy. Now guys, the problem could have been asked in a different way. Let's say theta would have been in place of 30, I could have written over here 45, and let's say phi would have been 45. So 45 plus 45 again would give you 90 degrees. Let's say theta is 20 degrees, and in that case, let's say phi is 70 degrees. This is also the case of a ladder. Again, the sum is 90 degrees. So in all the cases, in all of these combinations, let's say theta is 10 degrees, in that case phi would be 80 degrees. In all the combination, you see that theta plus phi is working out as 90 degrees. And in all the cases, the front and top views, both of them will stay perpendicular to xy line. So this is the best explanation which I can give. Okay. Now the next problem, the 8th one. Man, this was a very hard nut to crack. Very difficult question. Oh, it took me a lot of time. Okay. So now do read this, and I would suggest you to read this problem twice, thrice, 4 times, 5 times. Really difficult. Okay, pause the video and do read this and try to solve it yourself. Try to imagine what is the case. Okay, now this is associated with traces. First of all, let me tell you. And as far as trace is concerned, it is a point that is obtained when you extend a line in a particular direction. If on extension of a line it meets the horizontal plane at a certain point, then that point is a horizontal trace. And if on extending the line it cuts or it intersects the vertical plane at a particular point, then that point is a vertical trace, right? So this was the definition. Now, if a line is inclined to both HP and VP, you will be getting both the traces, that is horizontal as well as vertical trace. Okay, fine. Let me read the question. For a line situated in first angle, so the line is situated in the first quadrant, you can say, above HP and in front of VP. Which of the following options is not correct? Now this particular problem can be solved by eliminating the options. So whichever option is correct, you eliminate that option and try to focus on the remaining options. Let us read this first case. HT and VT may lie below XY. Let me read that once again. HT and VT may lie below XY. Okay, both of them, horizontal trace as well as vertical trace, are lying below XY. So just take a look at this animation. Okay, all the quadrants are showing, and if I can just have a line, end A and end B of the line, if I just extend the line, okay, from A, what will happen? It would intersect the horizontal plane first, and then it would go back, go down, and it will also intersect the vertical plane. In that case, when you give it a rotation, you can have the view. Anyway, there is a line. On extending the line, it intersects the horizontal plane first, then it further goes down and intersects the vertical plane. So there are 2 points. First of all, we get a point over here on the horizontal plane, that is a horizontal trace, and on further extending the line, we got a point on the vertical plane, and that is the vertical trace. Now, we want to draw the projection. So what do? We follow the rotation protocol. Okay, and horizontal plane in that case has to be rotated by an angle of 90 degrees in the clockwise sense. So when you do that, you have an XY line, and below that XY line you are going to have both the points. Remember this, both the points, that is horizontal trace as well as vertical trace. So statement 1 is correct. Okay, so leave it. We want to select an incorrect option, right? So let us take a look at option B. Option B rather is also interesting. Okay, HT lies below XY. Okay, HT lies below XY and VT lies above XY. This is also true. Let me tell you why. The scenario is like right here. So we've got principal planes, fine, we've got a line. And the line has been positioned in such a manner, if you extend the end A, okay, towards the vertical plane, you'll get a vertical trace. And if you extend the end B towards the horizontal plane, okay, or in the direction of horizontal plane, you will get the horizontal trace. So again, what do we need to do? We need to follow the rotation protocol, and on that basis, we will be rotating this horizontal plane. When we do that, above the XY line, we already have a vertical trace, and below the XY line, we will have a horizontal trace. So this option also is true. Okay, so 2 options are out of the way, 50-50 done like. Then we've got option C. Let me read that. And if this is also correct, then automatically option D would be right. Okay, fine. HT and VT may lie above XY. Both horizontal as well as vertical trace are lying above the XY line. And here, if you take a look at this, now this has been positioned in such a way, on extending that end A, it will first cut the vertical plane. Therefore, above the XY line, what do we have? We have a vertical trace or a VT, and then it will go further downwards and behind that vertical plane, and it will intersect the horizontal plane. And there we are going to have the horizontal trace. Again, we've got a vertical trace on VP, we've got a horizontal trace on the horizontal plane. What will we do to make the projection? We'll rotate the horizontal plane in the clockwise sense. And when you do that, above the XY line, or rather you'll have the XY line above which you will have both. What? HT as well as VT. So HT and VT may lie above XY. That is also a case, also a scenario which is perfectly alright, no problem. Okay, this is possible. So automatically the option number 4, you don't even have to think about it. That is wrong. That is incorrect. So the option is option D. Done and dusted. Very easy. Okay. Let's now switch over to problem 9 and go ahead and read this. A 90 mm long line PO, the name is PO, fine. Inclined at 30 degrees to the HP. Okay. So theta has been given. Name of the line is what? The name of the line is PO, and with respect to PO, theta has been given as 30 degrees and 45 degrees to the VP. So the inclination that the line would make with vertical plane is 45 degrees. Has its end P 15 mm above the HP. So any distance associated with HP, small h, okay, is rather denoted by small h. So this is the for endpoint P, and this distance has been given as 15, fine, and 25 mm in front of VP. DP, distance from vertical plane, is equal to how much? 25. Now, both these distances are in millimeters. The other end will lie in. Well, this is a very confusing question, and most of the people won't even think much and they'll automatically tick mark option A. Okay. The options have been given in such a manner that people, it really tests your skill, tests your rather depth of knowledge. Someone who has a surface knowledge of engineering drawing would go ahead and automatically select option A and then he'll move forward. Okay, but that's not the right option. That's not the only right option rather. Let me discuss this. So we've got a line PO and the location of the end point P has been given to us. H and D has been given to us for point P. Okay, in the form of 15 and 25, right? 15 and 25. Perfect. No problem. Theta and phi has been given to us 30 and 45 degrees. Okay. So what are the possible scenarios of end O? Point P is fixed, but what about end O? Where could it lie? Just take a look at this. It could lie in the first quadrant itself. Okay. How? Let me tell you. Now, first of all, it is possible that the line would be making an angle of plus 30 degrees and then plus 45 degrees over here, or minus 45 degrees over here, backside. If it makes an angle of 45 degrees towards this side, then both the endpoints are in the first quadrant. Okay. Well, point P will always remain in the first quadrant. That is for sure. Again, let me explain you. So we've got a line over here and both the angles 30 degrees and 45 degrees this way. This way it has been taken. So when you take it like this, you will have endpoint O in the first quadrant. But if you take the 45 degree angle like this, okay, anti-clockwise when you see that entire scenario from the top, in that case the endpoint P will be remaining stay here, but endpoint O will go behind the vertical plane. That means it will go in second quadrant. So these are two possible cases. Again, what did we keep fixed? We kept fixed angle 30 degrees like this. Okay. Then we rotated it 45 degrees over here. Okay. Pulling it towards us by an angle of 45 degrees and then pushing it behind by an angle of 45 degrees. So we understood that the endpoint O could have been in the first quadrant. It could have also been in the second quadrant. Possible cases. There could be two more cases. Let me tell you what they are. Instead of taking this 30 degree angle above, you take it below. Okay. Even here, if you take the 45 degree angle towards yourself, you will have the endpoint O in the fourth quadrant. And if you take this 45 degree behind, you will have the endpoint O in the third quadrant. So this particular case is basically a combination, and projection for this particular case can happen in all the four quadrants, because nothing regarding which quadrant is this line lying was said to us. We had to work it out. So this is possible in all the four quadrants. So the right option is any of these. Option D. Perfect. So 9 problems done. Okay, now let us take a look at the problem number 10, and I think you can actually work it out very easily. Okay. If the front and top views of a line are inclined at 30 degrees and 45 degrees to the reference line, okay, the true inclination of the line will be. Now, try to read these questions once again. The angle that the front view, the final front view and the final top view makes with XY line is denoted by alpha, okay, and this is beta. This is the angle made by final front view, and this is the angle made by final top view. It would be better if I can just rub it off. Okay. And there is something that I already told you. Always remember, the angle that true length makes is always less than alpha, and the angle that true length makes with the VP rather is always less than beta. So do we have an option like this? Do we have an option? The true inclination of line with HP. So true inclination with HP is something which is denoted by theta, not VP, but with HP. And this theta will be, no, it won't be equal to 30 degrees. It won't be equal to 40 degrees either, but we know that it will be less than alpha. How much is alpha? And the value of alpha has been given as, let me see once again, alpha has been given as 30 degrees. So it will always be less than 30 degrees. The correct option is option C. Done. 10 problems done. Let us take a look at problem 11. Then here we go. If both the front and top views of a line are perpendicular to the reference line. Okay. Remember, both front and top views are perpendicular to xy. And this is something that I had discussed in one of the problems just before. Okay. So front and top views are both perpendicular to xy. The true length of the line with HP, or rather the true inclination of the line with HP and VP may be respectively. As I have told you, let's say you've got a line like this, X and Y, and let me use a different color. Let's say the front view of a line looks like this. That's the front view. And its top view also looks like this. Right? Let's call this A dash, B dash. That's the front view of the line, and that's the top view of the line. Let's say this is A and B. Now, both of them make 90 degrees angle. Okay. So what is this case? This case is nothing. Whenever you have a scenario like this, whenever you have alpha is equal to beta is equal to 90 degrees, always use this mathematical expression. Theta plus phi is equal to what? 90 degrees. And this is something that I had discussed in one of the problems before. Okay. So what are the options? Do we have an option where on summing theta plus phi we get 90 degrees? Try to take a look at these options. So the first option is 15 plus 75. Add both of them. Do we get 90? Yes, we do. Option 1 is correct. Option A is correct. Then we have theta 60. 60 plus 30 is again 90 degrees. This option is also correct. Option C is 45. Both 45. Again, 45 plus 45 will be 90 degrees. So all the options are correct, man. So the correct option is option D. This is the right option. Okay. All the cases are possible. All right. Now let's take a look at problem 12th. Okay. It goes like this: which of the following statements are correct? So the first statement is, if the front view of a line is parallel to xy, the front view of a line is parallel to xy, its top view gives the true length. Well, this is something that was explained just a few questions before. We'll take a look at this. The line is parallel to HP, inclined to VP. The front view, if you take a look at it, is a straight line, okay, parallel to xy. Top view shows the true length. It's perfectly right. Top view TV showing the true length, that is TL. So the statement 1 is absolutely correct. Correct. Put a C over there. Now let us take a look at statement 2. Statement 2, well, this PL is nothing but the plan length. Plan is a civil engineering term and it corresponds to the top view. Plan length, top view length. So top view length of a line would be constant if angle phi is constant. Well, top view length has absolutely nothing to do with angle phi. Top view length completely depends on angle theta. Okay, it's like this. Let me give you a demonstration. Is the scale. So let's say this is the line. Okay. Let's say if I keep it absolutely parallel to HP as well as VP, and if I incline it like this, let's say right now the angle phi is 30 degrees. If you take a look at this line, let's say this line is 10 centimeters long. If you take a look at this line, it will appear 10 centimeter long. No problem. Now let us vary the angle. Let's say we change the angle phi from 30 degrees to 45 degrees. And still, on taking a look at this line from the top, you'll still see how much? The same true length, same 10 centimeters. So let me make a claim that true length of a line, rather, or top view length of a line has nothing to do with the angle that it makes with VP or phi. Okay. It depends on angle theta. Let me tell you why. If I keep a line like this, parallel to HP, Okay, this is parallel to HP and parallel to VP also. And what I do is, I do this. Let's say this angle over here that it makes with, this is still parallel to VP, but it is inclined at a certain angle with HP. So when you take a look at this line from the top, you will observe that the length of the line will reduce, isn't it? Obviously, if I incline this angle further, if I give it a further inclination, the length of the line, apparent length of the line, when you keep on viewing it from the top, it will keep on decreasing. And if I make it like this, if I do this angle 90 degrees, then automatically the top view of the line would become a point, right? So this statement is absolutely pathetic and incorrect, because plan view depends on theta, it does not depend on what? On phi. Anyway, third, let's take a look at this. Horizontal trace of a line is seen on top view. Yes, horizontal trace of a line is seen on top view or on extension of top view. We've already seen a lot of things regarding traces. Now, whenever you want to see the horizontal trace, that is something which is obtained on an horizontal plane. Okay, that's correct. So on horizontal plane, we always get a top view. So top view is associated with a horizontal trace. Always remember that. So the correct options, 1 is correct, statement 1 is correct, statement 3 is correct. Do we have an option like that? Yes, 1, 3, option C. Okay. 12 problems are done. Let us take a look at problem 13, and it goes like this. Which of the following statements are correct? So the first statement is, if top view of a line is the point view, top view of a line is the point view, then the line is perpendicular to VP. It doesn't look like. Why? Now, just try to think. On watching a line from the top, it appears as a point. With respect to which principal plane, with respect to which HP or VP, would it be perpendicular? It would be perpendicular obviously to the horizontal plane. And here the statement claims that it is perpendicular to VP. No, absolutely not. Take a look. This line is perpendicular to HP and parallel to VP. It appears as a point from the top. Okay, that's it. So if a line appears as a point from the top, it is going to be perpendicular to the horizontal plane, not perpendicular to VP. So the statement 1 is absolutely incorrect. That's gone. Statement 2. The plane perpendicular to VP and inclined to HP is called. Okay, let me educate you on auxiliary inclined plane and auxiliary vertical plane. So first of all, take a look at this case. This is an auxiliary inclined plane, okay, which is inclined to HP and perpendicular to VP. Inclined to HP is auxiliary inclined plane. Remember this. Inclined to HP and perpendicular to VP. Auxiliary inclined plane, AIP. And then we've got AVP. This is inclined to VP. AVP is inclined to VP and perpendicular to HP. So what have we been said? The statement goes like this: the plane perpendicular to VP and inclined to HP. Now if it is inclined to HP, it is an AIP, that is auxiliary inclined plane, and here it claims that it is AVP. It's a wrong claim, man. Incorrect option. Statement 3. Statement 3 says the projection on an AVP is auxiliary vertical plane, is called auxiliary front view. Well, that's right. If you try to have a projection on the auxiliary vertical plane, you will always get an auxiliary front view. In auxiliary inclined plane, we get an auxiliary top view. Remember this. This is something that you should drill inside your mind. Projection on an auxiliary inclined plane is the top view or auxiliary top view, and projection on an auxiliary vertical plane AVP is an auxiliary front view. And if you want to know more, well, I'll provide a link below for a video on the concept development of auxiliary planes. Go ahead and watch that video. It's of 15 to 20 minutes. So devote your time towards watching that video, because that is going to really develop a sense of understanding regarding auxiliary planes. I do suggest you to watch that video. It's very good. Okay. So the only correct statement is, well, it's statement 3. Okay. The projection on an auxiliary vertical plane is auxiliary front view. That's the correct statement. Correct option is, well, that's option B, that is only 3. That's right. Okay guys, now let's move forward for problem 14th, and here we go. If a line is inclined to HP, and parallel to VP, this is a very simple case. It will have line inclined to HP, fine, parallel to VP, no problem. If you extend this end A of the line, it is definitely going to intersect the HP. That means you are going to have a horizontal trace. Very straightforward, very easy. Only HD, option A is correct. Okay, problem 15th, and here it is. If a line is parallel to both reference planes, by reference plane I mean to say both HP as well as VP, it's parallel to both HP and VP, then which of the following statements is wrong? Okay, the options are very absurd. Let me tell you the full form of those options. TL corresponds to the true length, PL corresponds to the plan length, okay, top view length, and EL elevation length or the front view length. Now it would get easier. So line is parallel to both HP as well as VP. You can clearly see that. Okay. We need to work out which one of the option is correct. Incorrect. Okay. So the first option says true length is equal to plan length. Yes. The true length, whatever the true length is, that will be visible from the top. Okay. That is the top view. That is the plan length. Second option is true length is equal to elevation length. This is also correct. Why? Because it is absolutely parallel. So when you take a look at this line from over here, from the front view length or the elevation length will be equal to the true length as it is parallel. Third option. Third option is wrong, man. Why? The reason being, true length is greater than elevation length. We've seen that true length is equal to the elevation length. So it cannot be greater than the elevation length. And fourth option, alpha is equal to beta. Well, you don't even have to worry about that, because the angle that the front view makes and is alpha, and angle that the top view makes is beta. And in this case, alpha and beta are 0 degrees. Why? The reason being very simple, as it is parallel to both HP and VP. That's the reason. So the correct option is option C. Done and dusted. Okay guys, now let us focus on problem 16, and here we go. The projection of VT on XY. Projection of VT on XY, that is V is seen on. Okay. Now this is going to be very easy, and let us try to understand this with the help of this very simple illustration. So what I've drawn right now is an XY line, and let's just say this is endpoint A dash, and that's A, and let's say this is the final front view. This is going to be B dash, that's the locus of B, and let's say this is top view. Let's say this is B. Now on extending the front view, it intersects the XY line somewhere here, and this point is referred to as H. Okay, and if you want to have a vertical line through H, it's like this. Then on extending the top view, wherever it intersects, like here it does, this intersection point is V, and this is something which was asked in the question. V is seen on the extension of top view. This is V, and if I can just make a perpendicular line through V, okay, watch carefully. If you want to find the vertical trace, just extend this. That's the vertical trace. If you want to find the horizontal trace, just extend this. Here, this is the horizontal trace, and this is basically a methodology we follow to find and work out the trace of a line. That's it. So on extending the top view, you get this V. This was asked. Option A, TV or extension of TV. Done. 16 problems over. Problem 17, and it goes like this. If theta plus phi is equal to 90 degrees, then which of the following statements are correct? Again the same stuff. Theta plus phi is equal to what? 90 degrees. And I've already told you this is a case of a ladder whose one end is in contact with the wall while the other end is in contact with the ground. So remember, the front and top views are going to be perpendicular to XY line. That means alpha will be equal to beta is equal to 90 degrees. So option 1 is correct. Yes, we want to select the correct option. But straight away don't take option A. Read the other options also. Second option, side view will be equal to the true length. Take a look. In the front view, the length of the ladder, the true length of the ladder will not be visible. In the top view also the true length will not be visible. But when you take a look at the scenario from the side, yes, you will be seeing the true length. Okay, that's why second option is also correct. What about third option? Third option is pretty obvious, which we have seen whole lot of times. Front view is obviously going to be perpendicular to xy line. Okay, so whenever there is this mathematical condition theta plus phi is equal to 90 degrees, always remember front and top view, both of them will be perpendicular to xy line. That means alpha will be equal to beta is equal to 90 degree. And obviously this is a repeated option, I would say, because option A is also conveying the same information. Anyway, option D is correct because all the options are correct, all of the above. Fine, that's it. Problem 18th. To obtain the point view of a line, the auxiliary plane is set. Well, auxiliary plane rather is a dynamic plane, you can say, because in case of reference or principal planes, they are fixed. Okay, HP is fixed, VP is fixed. Rather, you can have an auxiliary plane, say this over here, you can keep it like this and have a projection over here, you can keep it like this, have a projection over here, you can keep it whichever way you want to. So to obtain the point view of a line, the auxiliary plane is set. Let's say this is the line. Okay, this is how the line has been kept. So this line would appear as a point from where? So we'll set the auxiliary plane like this. How? Absolutely perpendicular to this line. Okay. Now, had the line been making certain angle, let's say if the line is like this, then in that case the auxiliary plane would have been kept in this way. So from the front you would see a line, that will be the line view of this auxiliary plane, and then there is this original line. Again, the angle made over here is 90 degrees. So whenever you want to see the point view of a line, you will always have to keep the auxiliary plane perpendicular to the line. Do we have an option? Perpendicular to the true length, yes. Option A. Okay, you're fortunate enough to have correct option in the form of option A. Okay, problem 19th, and here we go. To find theta. Theta is nothing but the true length that the line makes with the horizontal plane. The auxiliary plane is set. Okay, two things that I need to tell you. Whenever you want to find the true length by the auxiliary plane method, you set the auxiliary plane parallel to the top view. When you do so, you will have the true length making an angle theta. Okay. In the same manner, if you want to find the true length making an angle phi with the VP, what do? You set the auxiliary plane, parallel to the front view. Let me reiterate. Here in this problem, we want to find the what? Let me read that once again. We want to find theta. Okay, so in case of finding theta, what you need to do is you need to set the auxiliary plane parallel to the top view. If you want to find phi, you will set the auxiliary plane parallel to the front view. That's the way forward. Always remember this, and this is something on which I have done a lot of problems. I would appreciate if you guys can devote some 15 to 20 minutes on watching those problems. Your concepts will become much strong. The links to which can be seen in the description down below. Okay, so the correct option is parallel to top view. Want to see the true length with angle theta? Set the auxiliary plane parallel to top view. If you want to see the true length with angle phi, set the auxiliary plane parallel to the front view. Done. Problem 20th, and here it is. To obtain the true length of a line, auxiliary plane is set. Okay, you know that what the right option is. If you want to find the true length, set it either parallel to HP, not HP, set it either parallel to the front view or set it parallel to the top view. If you set it parallel to the top view, you will have the true length with theta. If you set it parallel to front view, you will have the true length with angle phi. So the correct option is option B, and that is parallel to front view or top view. Last problem in this series, and here it is. If the apparent and true inclinations of a line with HP are equal, apparent and true inclination, okay, the line is, if the apparent and true inclinations of a line are equal, it's something like this. Apparent inclination is alpha and inclination with true length is theta. Okay, this is the real inclination and this is something which we see. Both of them are equal. Then the line is, this is also a very simple case. Take a look at this animation. You can clearly see that the line is inclined to HP, fine, and line is parallel to the VP. So this inclination will be clearly seen in the front view. That is angle theta and that is also angle phi. Both of them are visible in one single view, theta as well as phi. So this is the only case. And whenever such a scenario happens, you will say that the line is inclined to HP and it is parallel to VP. Had this line been slightly inclined to VP, then both of them would have been different. Theta would have not been equal to alpha. Okay, if there was phi, then theta would have not been equal to alpha. As long as phi is equal to 0, then theta will be equal to alpha. So the correct option is, it's option B. That's it. So we are pretty much done with today's class. I expect that you must have understood all the problems, and most of the problems were very deep and they really require a lot of understanding of orthographic projection, projection of point and projection of lines. So guys, that was all for today from my side. I'll see you again in the next video, which is probably going to be based on projection of planes. Until then, take care and have a nice day. Thanks for watching.